Hello, everybody. This is Michael. I think there's some feedback here. Let me see if I can. Okay. Eric, would you mind muting your? Actually, for those, if you don't mind muting your microphones, I think sometimes there's some feedback that could result from too many mics open. Okay. Okay. So my name is Michael. Hello, everybody. So like a lot of things these days, this is also virtual meeting. And today's topic is so regarding the DDM, or Digital Diagnostic Monitoring. That as most of you know, that those are the really main interface that we've been using to monitor information from transceivers. Yet, I mean, unless you are actual user of using transceivers all the time, sometimes the details might, may not be well known. So I thought this would be a good topic to just discuss, having an informal presentation from my colleague Eric Mark. Again, that as usual, our presentation will take maybe 15 minutes, and we'll save the last 5-10 minutes for your questions and answers. But during the presentation, please feel free to stop and ask questions either through the chatting window, or, I mean, if you have urgent question, we have a small, pretty intimate audience, so you can, verbally stop and ask questions if you like. Okay, so again, I appreciate everybody joining this Friday afternoon, and without further ado, I'll turn it over to Eric, who will give you a pretty good overview of the DDM and how it could be used for our advantages for getting transceiver information. Okay, so Eric, please.
Hey, Michael, I want you to do me a favor.
Sure.
When I show the screen, when it's okay, you give me feedback, right? Because I don't know for sure, because I use two screens when I do a PPT.
Okay.
And it shows on the other screen, and I don't know if they see it or not.
Okay, so yeah, I'll give you comments.
Yeah.
If okay.
Just give me feedback.
Okay, sure, no problem.
And you need to give me control. Set the host disable.
Yeah, so I think Shantanu, if you could give a control to Eric. Okay.
Can you see my screen?
Yes.
Okay, good. Yeah, so good. I never tried it before because it shows up on my second screen. So the first screen is garbage, right? So good. So let me start. My name is Eric Mack. I just recently joined Vitex. So today I'd like to share with you my knowledge on the DDMI. I would share with you with like a user standpoint. So there are things I would not say due to my focus on this, right? So, but you can ask me. Maybe after the meeting, I can send you the material and I can talk to you. Right? Okay. So the topic is to use the transceiver DDMI effectively. So what is DDMI? DDMI is a digital diagnostic monitoring interface. So you can use those monitors to make your transceiver work effectively. And also you can see what you do, and sometimes you can sense if if your transceiver is degrading, right? And I will explain that to you later on, how what to look for. Basically, you can see the second group of bullets, and it groups into 3 different standards. The first one is called SFF 8472. Basically, it involves the SFP and SFP plus, as you know, which operate at 10G. And one thing very particular is that at that time, a 10G SFP plus and only which is different. So it's one lane. We call it one lane. And as the technology progress, and we into 4 lanes, right? You know, you guys might remember for 40G, starting from 40G and 100G and so forth, we talk about 4 lanes of data. So as you can imagine, the information is 4 times per transceiver, right? So here comes the standard called SFF 8636. And during the last year or so, especially this year, the 400G product comes along, and it has 8 links from the host, right? Basically 400G gigabits per second. And with that, besides the number of links, they're so complex. There are so many things the user wants to know, and also controlled on a transceiver standpoint. So I will show you later on. The CMOS is different. So I would explain to you later. So going down the list is that the purpose is to help the users to operate the transceiver more effectively, right? So the monitors, we're talking about 5 basic monitors. Those monitors never change. Under those 3 standards, they are still the same. Those are common type of monitor. First one is case temperature. Now it's case temperature, all right? Not nothing else. At the beginning, there was a confusion in the industry and what it means by temperature. But I think we settled down on case temperature. Everybody abide by this standard right now. The second one is supply voltage. Third one is receiver input power. And the fourth one is transmitter laser bias current. And the last one is transmitter output power. Okay. If you have a question, please interrupt me. This slide shows the standard for SFF 8472 for SFP and SFP plus. Yeah. So as I circle in the middle, and the red circle there shows you where you look for those monitors. So you can see the address is A0, the first column. The second column is A2, right? Which is basically page 0, right? And then your page 2, page 1, page 2, page 3, all the way to 80 hex or FF even. And most of them are internal tables for the supplier. So on here you can have 2 pages most likely on the 10G EEPROM. So you can see the location I identify is each monitor has 2 bytes. You can see, right? 62 to 97 all the way to 104 to 105. So I show you how to calculate that later also. And the next page, the next slide would be the second group I was talking about, 40G and 100G QSRP. And the one I circle is the location of the monitor. And you can see on the right-hand side, except the temperature and VCC, which are common to a module, right? They are not divided by links, right? So those two are per module. But you can also see down there the receiver power, transmitter bias, and transmitter power. They all have 4 links. That's why it starts to grow now. So yeah, so you have page 0, page 1, and page 2, page 3, basically. Now you can you have a sense this is much more organized now. So okay. Now here comes the CMOS. The CMOS now is currently is called CMOS 4.0. CMOS 4.0 is a very capable EEPROM standard. So I will explain to you later on. So the first, the monitor, you can see the case temperature, VCC, and or tech current, and or temperature, laser temperature is in the first page, the lower memory. So now the last 2 parameters, like the tech current and laser temperature, are optional. I see this from some vendors' table. Some of them display it, some of them don't. So there is still not a must-have parameter. But the first 2, the temperature of the case and the VCC are required. So then you jump to different table now. They don't follow each other. Now then the rest of the monitor, namely transmitter power, transmitter bias, and receiver power, would go to page 11 instead. And at the location, I already put it there. And what I want to touch on this one is the capability of the CMOS 4.0. You can see page 13 and page 14. It has the bit error rate monitoring capability. It shows you the bit error rates on all 8 links. And also there, you can look back and forth, self-look back to on the host side and on the line side also, in order to troubleshoot your transceiver. That's how I like it. Yeah, it should be like this. So before, the transceiver is just like a black box, right? You cannot do much. But with the CMOS 4.0, you can really go into it. There are lots of parameters. Not just the host can control it. On the transceiver itself, through the I2C, you can control it as well. So, which is very nice. So this page, I just want to show you the CMOS 4.0. You can see this is all from MSA, the CMOS 4.0 document. And the page 13, you can see there's 4 times a look back. You have line look back from the transmitter, and line look back from the receiver to the transmitter, and the host look back on both sides as well. So and also on page 14.
Excuse me, Eric.
Yeah.
Hi, sorry. Yeah. I think that you did the presentation mode, and at least on my screen, it kind of shows at now that it's a little difficult to see. So is it possible to get out of the presentation mode?
Oh, okay. That's the feedback I need. How about now?
Yeah, okay. I hope it's better for everybody. Yeah, it's okay. Much bigger. Okay, great. Thanks.
Yeah. So I just stay here, right?
Okay.
So, okay. Yeah. Let me know if there is anything else.
Thank you.
So on page 14, you can see all the bit error rates, right, on all 8 links, right, which is very powerful, right? And there are things I have not shown. Okay. But those 2 are pretty useful for the user, right? So it's in page 13 and page 14. Okay. Now let me go to the next slides. So of those 5 basic parameters, I put it up just for your convenience. The range, I state the range, I put it down directly from the MSA. So temperature, VCC, bias current, transmitter power, receiver power. But keep in mind that the vendor do not have to follow the range, right? So they do the range basically is from the spec, their own spec, whatever the spec is, they put the range in, they calibrate for the spec. And I put in the Excel equation just for your convenience with 2 cells, you know, the first byte and the second byte. You can do the same thing. For instance, the example would be for temperature for 1C08, it will translate, if you use the equation like that, it will translate to 28.03 degrees C, right? So vice versa, all the way for those 5 DDMIs. Okay. If you have a question, interrupt me. And I'm going to the last one because I know this one is pretty, you have to be careful when you use a DDMI. What I want to point out is that this is a very typical DDMI table the supplier will guarantee to you. You can see on there are 2 columns, very important. One is the range. So again, the range is per their products, right? But that range also, they are telling you is linear per with the accuracy they specify per that range. So they must carry, for instance, let me jump to the receiver power, minus 13.7 to plus 2.3. In their range, they have to guarantee plus or minus 3 dB for you, right? So it's internally calibrated. Okay, so also let me go by bullets, right? So that go through each one. Now for the temperature, you can look at the DDMI to tell how warm your your module case temperature is, right? Basically, with and without fan, you can see the difference. You can see change, right? So that's one. The VCC, I want to emphasize on VCC because nowadays there are lots of switches. They populate a 1U switch with 32 modules. As you can imagine, it's very warm. I would say hot. And one way this thing can hurt the user is that if all populated, when you turn it on, all of them, if all of them turn on, under such a high current surge, the VCC might drop below the operating range. Then you use this VCC to monitor to see if that is the case. Okay. That, I use it all the time when I see a switch is fully populated because most of the time the VCC drops. Okay, when it drops to a certain level, plus or minus 5%, and it will violate the operating condition on 3.3 volts. The third one will be the bias, the laser bias current. Well, together, the laser bias current together with the laser power, you can know how the laser is operating and how healthy the laser is, right? Some of them, you know, if the laser output power dropped by half, that means 3 dB down. When the current, the operating current doubles up, that means the laser is dying. So that is something you watch out. When sometimes you can see it. Sometimes it's not that severe, but you can sense it, how healthy your transmitter is, right? So the fourth one would be to use the transmitter power and the receiver power to calculate the link loss. So that can be done. But keep in mind, you can see both parameters is specified by plus or minus 3 dB. Altogether is plus or minus 6 dB. So it will throw you off completely if you look at it not as a reference, but as an absolute number. Never use it as an absolute number because the tolerance is too big. So I encourage when you operate a transceiver, at the beginning, you get a set of beginning of live data, right? Put it somewhere, either from the supplier or from what you measure. And then when you try to troubleshoot later on, the transmitter, look back on your beginning of live data and see if that thing changes, right? So that will give you, because of one calibration, the calibration is fixed. Once it's fixed, for instance, like if it's -3, always stay at -3. That won't change. So, but then you know, by looking at the beginning of live data, then you know how accurate the measurement is, right? So also, yeah. So the last two bullet points, I just want you to watch out for the accuracy and the range. Yeah. So that's the end of my sharing and my talk, and I am asking if you have any questions that I can answer for you.
So Eric, this is Shantanu.
Hi, Shantanu.
So I had a question.
Yeah.
So as you mentioned that transmitter power and receiver power should not be considered as absolute values when measuring through DDM. So what exactly is the mechanism which they use to monitor the transmitter power? Do they actually drive the laser circuit, or?
Yeah, that's a very good question. The way they calculate the number for you for the DDMI is also indirect, right? So it's not like a power meter. You can measure a power and then display the value. They just use it to calibrate it, right? So for instance, they measure the output power by looking at the current, right? So at the calibration, when they build the transceiver. So when the laser start to operate, right, in the customer's place, and this parameter cannot be from the power measure, right? Because there is nobody to measure the power, right? So they just use the current, which was used to calibrate the power to show, right? So by itself is indirect measurement, right? So I see people use this parameter like a power meter, and I strongly discourage them to use it. For referencing, it's okay, but not for absolute measurement. Yeah.
Okay. Thank you.
Yeah, you're welcome.
All right, thank you, Eric. That was actually, I learned a lot myself.
You're welcome.
Yeah, so I know this was a briefer presentation, and we didn't want to take up too much time on Friday afternoon, so we purposely made it a little maybe shorter than what some of our customers would like. But if you have any suggestions for feedback, please send us an email to our marketing email, and then any topics that you'd like to know, just in general, transceivers, technology, trends, any questions you have. I mean, that we'd love to hear from customers and pick good topics that's useful to everybody. Okay? Great. All right, thank you so much for joining us, and everybody have a great weekend. Okay.